everybody. So today we're going to talk about the law of cosines. So earlier in this series, I reviewed the congruence axioms and when you can solve a triangle. So case one, that was where we knew one side and two angles. So that would be a side angle angle or angle side angle. And then we had case two, which was two sides and one angle not included in between. So that would be knowing a side, and then an angle. And we have discussed that this could make more than one triangle. And then we have cases 3 and 4. So case 3 is where we have two sides and the angle included are known. So that's SAS, side, angle, side. And then case 4 where all three sides are known. So that's side, side, side. All right. So these cases use the law of cosines. So that's what we're going to talk about. So a key for case 3 and case 4 is the triangle side length restriction. So what is that? So the triangle side length restriction says that the sum of the lengths of any two sides must be greater than the length of the remaining side. So this is actually going to be very important in helping you decide how you want to solve your triangles. And I will show you how to use this in a few minutes. So let's just jump right into it. Let's just see how the law of cosines arises. So, okay. ABC is going to be an oblique triangle, and so from here, I'm going to label my angles A, B, and C. All right, so let's orient A, B, and C with a coordinate system just to help us out, and then so let's have C be on the vertex, and we're just going to be really specific with how we set up this coordinate system. So we are being strategic, and we're making sure that B is at the origin. So this is just going to make our life easier in helping us understand how the law of cosines arises. So sometimes when you are solving things like this, you make strategic decisions that make it easier to label things. Okay, so now from there, I can label my sides. So I have angles A, B, and C. And then remember, it's always directly across from that angle. Here's side B, here's side A, and then across from angle C, here's side C. Okay, so now I will just go ahead and label the lengths of these sides. And this is where having this strategic place for B is really helpful. So this is 0, 0. This length is obviously A. So this point is A, comma 0. And then, right, this side, like we just said, is 0, 0. And then, so from here to here, so notice now we can create a right triangle, which we know all kinds of things about. And so from this right triangle, I can think about these different relationships. So, so if I think about, so here's my angle of B, and so if I just think about whatever this angle might be, so if I take sine of this, that's going to be opposite over the over the hypotenuse side. So that's going to be y over c. And then for cosine of b, so here's the adjacent over the hypotenuse. So that's x over c. Okay, so we've got all that labeled. And now let's keep going with this. So this point here then is also going to be the point, we're going to call this point x, y. So I've got this side x, I've got this side y. So I've obviously, if I start here from the origin, I'm going length x and up length y. So this will be the point xy. Okay, so I know we've got a lot of different things going on here, but this is all going somewhere, I swear. So now what I want to do is I want to solve for x and y, because I did kind of just erect these two other variables, right? It would be nice to keep everything in terms of A, B, and C. And if you look at these equations, right, it's not too bad really to solve for x and y. So let's go ahead and do that. So for this one, I'll just multiply by c, so I get y equals c sine b. And then obviously here, I'll just multiply by c, so I have x equals c cosine b. Cool. So now I can relabel this point. Instead of calling it xy, I can call it c cosine b and c sine b. All right. So now we have a fully labeled triangle, right? So I have my points of the triangle all labeled. This is happy, this is cool. All right, let's keep going. So now the question is, how can we find length B? All right, so let's think about this. We can use this little sneaky right triangle that we already created. We can now leverage this to help us answer that question. So I've drawn that in pink. So length B in this sneaky triangle, length B is obviously going to act as the hypotenuse. And so the cool thing is now if we have the right triangle, we can use the Pythagorean theorem here. So I am just solving for b. So I've got this side here. So this side is going to be height c sine b. That's this height b. And then minus this here is 0, 0. And then what is my length of this side? Well, this point here we know is c cosine b, and this point here we know is a. So we're really just using either the distance formula or the Pythagorean theorem, but I've looked at the lengths of each side, as you see here. I've subtracted one point from the other, or really one point here from the other, and plugged it in, and then I took the square root of everything. Okay, so now let's just hone in on this equation for a second, and let's think about this. Okay, so I started with this distance equation, and of course I could also get rid of the square root, right? I could just square everything and get rid of that square root. So let's think about this for a moment. So if I were to take a second and actually square everything, so squaring this right here, I have to just take that 2 and transfer it to the c, and then this sine will become sine squared b, so this one's easy to square. This one I have to FOIL out, and so if I FOIL this out, what I will get is c squared cosine squared b minus 2ac cosine b plus a squared. Okay, so now all I've done, right, is I've just blown out the calculations. But now what I notice is that I have a c squared here and a c squared here. So what's cool is that I could factor out that c squared. So I'm going to factor that c squared out, and I'm going to be left with sine squared b plus cosine squared b. And we know what this is, right? This is equal to 1. So actually, since this is equal to 1, this can really be just excluded. And so what I'm left with then is b squared equals c squared times 1 minus this other stuff. And from here, I can just rearrange it to make it look a little nicer. So I'll just put everything in alphabetical order. So b squared equals a squared plus c squared. So I just move the a squared here to the front, and then minus the 2ac cosine b. All right. And so this is one of the forms of the law of cosines. So hooray, we've done it. So that's where it comes from. Now you don't have to remember how to, you don't have to remember like the proof for it, but it's just, I think it's helpful just to see, or it's fun, or I guess you could say it's great party conversation. You can tell somebody where the law of cosines comes from if you're running out of conversations. Okay, well, yeah, okay, anyways, let's keep going. So the law of cosines, so we talked about it in this case, but really you can shuffle, you know, the sides A, B, and C around through the formula. So I've got the 3 forms of it here, so you can pause the video and, you know, read them over. But so you can see that it has this nice flow to it. So I think it's like easier to remember because, okay, so if I have a squared, so I've got BC, BC. If I have b squared, I have AC, AC. So at least one side just uses all those letters. And I'm sorry in advance if you can hear my dog barking. She is protecting the house as she likes to do. Okay, so this is the law of cosines. So we have seen, believe it or not, a special case of this in the past. The Pythagorean theorem where c equals 90, actually. So you didn't know it, but the Pythagorean theorem is actually a special case of the law of cosines. So in this case, my c is what am I trying to say? So my C angle is going to be 90 degrees. So if one of your angles is 90 degrees, so think about what happens with that. What is cosine of 90? Well, we know it's equal to 0. And so what that does is that allows me to drop this part out here, right? This 2ab cosine 90 will just drop out. So I'm just left with c squared equals a squared plus b squared. Cool. And notice, so the other thing, this is actually kind of important. So c squared is usually what? C squared usually corresponds to the hypotenuse. So this actually goes in line with that triangle side length restriction, that the sum of the lengths of any 2 sides must be greater than the length of the remaining side. So notice that, so the hypotenuse in a right triangle is the longest side. And so that is why it's actually c squared. The hypotenuse equals the other two, because this is actually the nature of the law of cosines, that the two smaller sides need to be on the longer side of the equation, I guess you could think of it as. So that's actually that you can see how that works even in the Pythagorean theorem. Okay, so this is a really great reminder of like how to set up your law of cosines problems. I'm going to reference that in a few minutes. All right, so let's start with our first triangle here. So I'm going to have my angle B is 72.4 degrees, A is 31.4, and C is 44.3. So here is that triangle. So here's my angle B, 72.4. And then here's A and C angles. And so then across from there, there's 31.4 and there's 44.3. All right, so now I can reference my law of cosines against this situation that I have. So I'm trying to fill in the other sides, but using the information that I have right now, what I'm going to want to do is I want to leverage the fact that I know this angle B. So this is a side angle side case, right? And so since I know the angle B, this is actually kind of telling me which form of the law of cosines that I need to use. So out of these three, if you have a side angle side situation, what you want to do is leverage the angle that you know. So this is the formula that's going to leverage the angle that I know. And so this will be the formula that I want to use. Okay, so now let's keep going. So I've chosen my formula, cool. And so from here, I now can just fill everything in that I know. So I know side A, I know side C, so I plug in A, I plug in C, here's A, here's C, here's the angle that I know. So in the case of a side angle side situation, the law of cosines is very nice because it just kind of, everything just kind of comes together pretty easily. And it's just going to pop out that other side B. So if I go through and I do the math, so I get B squared is 2,107.24. And so that comes out to 45.9. So now we know one of these sides, 45.9. And from here, we can use the law of sines. So I'm going to use the law of sines. So I've got 45.9 over 72.4. So I'm using my angle and the side that I have just figured out. And then I can figure out one of the other sides. So I'm going to go ahead and figure out my angle C here. So I know that this side is 44.3. So, okay, so if I go through and I do the math, so what I'm going to do is I'm going to multiply this side by sine C and divide this side by this number. So really what ends up happening is I've got 44.3. I multiply this side over to the other side, so that's on top, and then this part that was on top, when I send it to the other side, it goes to the bottom. So you can just see the parts of the calculation here. And so from here, if I calculate this, so I get that sine of C is going to come out to this 0.91 or 996. And so if I take the inverse sine function, I will get 66.9 for one angle. And then from here, so technically if you used the law of sines again, you would be able to find your other angle A, but just to keep things simple, what we're going to do is I'm going to take 180 minus these other two sides to get the remaining side. And so I get 40.68 for my remaining side. And so there you have it. So there is one case of the law of cosines. So now I want to take a look at another example. So I'm going to have side or triangle DEF with these sides. So let me just set up this triangle with the different sides. Okay, so now this actually is where that triangle side restriction is going to be important. So remember, the sum of the lengths of any two sides must be greater than the length of the remaining side. So what that means practically when you are setting this up is that you want to look at the longest side, and that is the side that you want to have isolated to one side. So when I am looking at my law of cosines, basically now what I want to do is I want to make sure that my longest side is going to be in this place here. Okay. Okay, so I have grabbed one of my Law of Cosines formula formats. So what I want to do is I just want to choose the longest side. That's the side that I want to isolate. And so then these other two sides, so let's see, I can just take the other two sides and then minus 2 times 42.6, 24.2, and then I've got this cosine of c. So obviously I don't know the angle in this case, so this is what I'm going to have to solve for. Okay, so let's just go ahead and let's just set up the math here. So if I wanted to solve for my cosine of c, so what would I have to do? Well, I would begin by subtracting off these two pieces here. So I am going to subtract those off to the other side. So let's call this 59.1 squared minus 42.6 squared minus 24.2 squared. And now that equals this negative 2 times 42.6 times 24.2 times cosine of c. Okay? And so then, to finish getting c by itself, I just need to divide by all of this stuff. And so I'm just going to get all these numbers kind of together so that I can just do one calculation in one go. So that's kind of my idea here. So let's see, and then 24.2. Okay, cool. So I need a little space. Cool, so here's where I am, and so now what I get is cosine of c is going to be equal to doing this whole calculation here. So if I do that calculation, so I will get, let's see, I punched this in and I got negative 0.5298, so on and so on. Okay, and so then if I take inverse cosine of that answer, so I get c equals inverse cosine of all this. So this will give me that c is 121.99. Just a friendly reminder, also make sure that your calculator is in degrees when doing this. Okay, great. So now I have one side. So now, if we go back to the triangle, I can label the side opposite of the longest side as 121.99. And sorry, I think in the formula, in the formula I did it as c, but it was meant to be the longest side. So sorry, but that's 121.99. Okay, so now from here we can use the law of sines to finish this out. So now I can use the fact, I can use 59.1 over sine of 121.99 degrees. Let's see, let's set this equal to 42.6 over sine of e. Okay, and so then I can solve for sine of e. So if I solve for sine of e, this is going to be, I'll just take 42.6 times that sine of 121.99, all of that over 59.1. So if I punch that into my calculator, I get that this is 0.61135 and so on. And so then if I take inverse sine of that, I get that E equals 37.69. Cool. And so then from there, so I can take just 180 degrees minus, let's see, what were my sides? 121.99 degrees minus 37.69 degrees. And I will get that my last side is 20.32 degrees, and that is that's my last angle, which was D. So just to round this all out, these are the three angles that I found. So just make sure, of course, you're doing like a test. You want to make sure it's like clear what those final angles are. And so we're all good with that. Okay, so I've got just two other application problems now that I want to talk through of how we can apply the law of cosines to that. So I've got two boats leave a harbor at the same time, traveling on courses that make an angle of 81 degrees and 30 minutes between them. So when the slower boat has traveled 65.2 miles, the faster boat has traveled 84.3 miles. At that time, what is the distance between the boats? Okay, so I've kind of just arbitrarily labeled everything, but so we have these two boats, and so they're both going in. Here's the harbor. We're assuming that they're going this direction because there needs to be this 81 degrees and 31 minute angle between them. And so I'm told that this boat has traveled 84.3 miles. This boat has traveled 65.2 miles. Of course, this is not drawn to scale, but you get the picture. And so this, I just arbitrarily called this angle C. So boat B, it will be boat 2, and boat 1 will be A. Okay, so now what can we do? We want to know what is the distance between these two boats. So if one boat is here and one boat is here, really what this is asking for, right, is what is this length C in between them. And so now with how I've labeled this, if I look at my law of cosines, so really what I want is I need to get this angle C, so I can use this formula here. So, okay, so I can just really plug everything in this case, right? This is going to come together really nicely. So this is one of those types of problems where the key to this is having that right picture, because once you have the picture, everything else kind of comes together. And you can see, right, you've clearly got a side, an angle, and a side. So side, angle, side is your classic law of cosines. And so then I can just plug everything in. So I plug in my 84.3 and my 65.2, and I just do all my math here, and it's going to, you can see just kind of what my calculations came out to. But what I get is that my C should be 98.65 miles. So that's one type of application problem that you could have. And then the other one, I just chose another one just to show you some ideas. So the simplest type of roof truss is a triangle. So let's find angle C to the nearest degree for the truss shown. So I think a lot of times, if you know nothing about trusses, I think you'd have to have a picture in front of you to do this. But so here is what my truss looks like. And so I'm told that I have these measures. So I'm given this. So I have this side, and this side for my roof. I don't know anything about roofs, so I don't know if this is reasonable. You guys can leave a comment and tell me whether this is a totally unrealistic roof, if it's totally silly. But now I've got this side situation, right? So the application here is really nothing too crazy. We have a reference picture to work from. And so now they're asking for what is angle C. Okay, so we have to be a little careful with this now, right? I'm being asked for angle C, but notice that that is not the longest side. So in general, when we use the law of cosines and we have this side situation, we really need to use it for the longest side, which is here. So the formula then that I'm going to want to use in this case is actually, I want to use this structure of the formula. So first I want to figure out what my angle A is, because that corresponds to the longest side, okay? So let me just, we'll state the formula. And then we can just fill in the pieces that we've got. So this is 12 squared, 10 squared, 7 squared, 10, and 7, and then I have cosine of A. So I have to start here, and then let's see if we can make the cosine look a little nicer. So I have to start here, and eventually I can work my way to C, but we'll get there. So, all right, so if I solve for A, so just remember, I can go ahead and take, so I have this -2 times 10 times 7, so I can subtract off the other numbers first. And then, oops, and I forgot my cosine, sorry. Cosine of A, 12 squared minus 10 squared minus 7 squared. And then I've got my cosine of A is going to equal this 12 squared minus 10 squared minus 7 squared, and divide all of that by -2 times 10 times 7. So I get that my cosine of A is 0.0357, and so then if I take the inverse cosine of that, I get that angle A is 87.95 degrees. Okay, cool. So now, now that I know that, now I can figure out what C is, right? So let me make a little space. Okay, and now I'd like to figure out what C is. So I'm going to do, let's see, 12 over sine of 87.95 degrees equals 10 over sine of C. And so then I get sine of C is going to equal 10 times sine of 87.95 degrees divided by 12. So I have that sine of C will equal 0.8328. And so then if I take inverse sine of that, I get that my C is equal to 56.387 degrees. Okay, and so now we have figured out what we needed. Cool. So just to finish this video out, let's review all the cases and just how to solve them, because we've done a lot now in this series. So with case 1, so that's where you know one side and two angles, so that was either side angle, angle, or angle, side, angle. We find the remaining angle, taking 180 minus the other two angles, and then we can use the law of sines to find the other sides. We had case 2. We have two sides, but one angle is not included in between. So this is side-side angle. So this could be more than one triangle, and so I should actually get rid of the more later, I suppose, because we did already talk about this. So this case 2, we talked about that we want to find an angle using the law of sines and then determine if there is ambiguity. And so we can find the remaining angle and the sides with the law of sines, but there could be two cases, and so we discussed all the different ways to handle that in the other video. And now in this video, we've discussed this idea of two sides and the angle included are known, so that's the side angle side case. So in this case, we want to find the last side with the law of cosines, and then we can find the other measures with the law of sines. So we saw some examples of that. And then finally, the side case, well, you want to find one angle using the law of cosines, but you do want to make sure that when you do this, that you start with the largest side, right? That's going to be what's isolated to the left. And then we use the law of sines to find the other sides and angles. Okay, and so that brings us to the end of this video, so I'm going to leave it at that. And if you found this helpful, I'd love it if you hit that like button. Otherwise, I will talk to you guys in another video. Bye!